Hello, everyone. Thank you for joining our Kubernetes Masterclass today. While we're waiting for everybody to get connected, I'll go over some of the housekeeping items before I hand it over to our presenter today, Datadog. So as you can see on our title slide here, the topic of today's masterclass is observing and optimizing your Rancher environment. Our speaker today is the next slide here is Kalin, technology evangelist from Datadog. Aaron, you want to say hello?
Hi there, everybody.
Hello and welcome. Thanks for being on today. And as many of you guys probably already know, I'm the manager of events here at Rancher. My name is Connie. I don't know if I mentioned that, but moving forward, so the masterclass, if you guys aren't familiar with the format, we'll do some presentation and then go into the demo. Our masterclass is usually run between 45 to 75 minutes, followed by official Q&A. However, if you do have any questions that pop up along the way, please feel free to ask them in our questions tab. You can see that on your GoToWebinar panel. And just type it in and we'll do our best to either answer it via text or at the end of the session during our actual Q&A. And last but not least, we invite you to join our Rancher users Slack. We have a channel there dedicated to Kubernetes masterclasses, so you can hop on over to slack.rancher.io to join the conversation. And as with any virtual events, we ask you to be patient. Sometimes things take a little bit to load, between changing presenters, demos, etc. So with that, I'm excited to get started with today's topic. So Aaron, I'm going to hand over presenter capabilities to you to get this started.
All right, so howdy everyone. I'm doing that only because it's Rancher, there's cattle involved, I can't help myself. So I'm sure that's not the first time she's heard that. Anyway, welcome to Observing and Optimizing Your Rancher Environment featuring Datadog. So I want to give a quick overview of kind of what we're going to be doing today, so you know what to expect. So this is the overview. We're going to be talking a lot initially about myself and kind of my background. Actually, not really a lot. Just be a quick, brief interview or introduction about myself and sort of my background, where a lot of this is coming from. I've got actually a lot of experience with Rancher and even Kubernetes in various deployments, which I'll allude to later on. We're going to talk primarily about the main event that you're here for, is talking about Kubernetes and observability. We're going to go into great depth and detail. It's probably the bulk of this. It's where most of the slides are. Probably could have broken it up a little bit more, but it's kind of the big thing. And because if we did this as just a presentation of just slides and stuff like that, we could have just done a pre-recorded video and called it a day. So we're going to follow this up with a live demo, so I can show you kind of how easy it is to get up and running, and then sort of what you get kind of out of the box with Rancher, and sort of the different things you should look out for when you're either getting into Rancher or if you're already experienced with Rancher. I know this is a master class, so even just by the title alone, I'm assuming you've got some experience there, but we'll go over that too. And then of course we'll have a Q&A near the end, though there will be some opportunities during this presentation for you to ask questions, and we'll do our best to answer them. I was supposed to have sort of another counterpart with me on my team that would help answer some technical questions, but ironically enough, there's another presentation going on currently about Kubernetes with some of my other teammates. So it'll be a little difficult, but if I can't answer something, I will do my best to get you an answer even after this call, okay? So let's start off with the basics. Hi, I'm Aaron. It's nice to meet you. I'm a tech evangelist with Datadog, which is to say I love to share great stories about technology. It's about the easiest way to describe my job. It's a lot of what, I love playing around with technology. I love learning about it. There's an ever-growing and shifting landscape, especially when it comes to Kubernetes. It is a very fast-moving target. If you're going to address me in questioning or anything like that, if you want to chat with me afterwards, I go by he, him pronouns. I personally have a little over 20 years of software development and system administration experience. I've deployed everything from little tiny Raspberry Pis sort of at the edge, all the way up to large globally distributed clusters for several ISPs. So if you want to reach out to me after the talk or anything like that, or give me some feedback, positive or negative, I really want to hear it. It's how I get better as a speaker. But also I just want to know, what you're thinking about this. Want to also gauge audience engagement, since we are not physically together. I can't give this class in person, so I would love to have some interactivity with everyone here. So that is my handle just about everywhere: GitHub, Twitter, Slack, etc. You'll find me in all those areas. So let's get to the main event: Kubernetes and observability. Let's talk about that today. So I'm going to be making some assumptions here because I may refer to Kubernetes as K8s. Sometimes while doing the demo, we're talking about it because it's a popular shortening of the name that you might have also heard. Plus, it's cute. K8s is K8s. It was even more fun for me when you had Chef making a habitat that could run on K8s, so we shortened it to Hates. But I can't get to do that these days as much, but Hates is totally even more fun. But K8s, hey, you hear me say that, that's exactly what I'm talking about. If you've never heard that shortening before, chances are you probably have if you've heard of Kubernetes. Speaking of that, I'm assuming that you've heard of or already know Kubernetes. I'm assuming that, especially by the master class here, you have an existing Kubernetes environment, even if it's not necessarily production. Maybe you're exploring it for your company. You've heard all the hype and you're kind of jumping on that hype train to see what all this Kubernetes insanity is all about. It's kind of eating the DevOps world pretty much as the most popular orchestration system out there. Speaking of, I'm also assuming that you already know what Rancher is, or you're examining it, because by way of you getting to this class, you kind of heard of Rancher, or maybe you're playing with it, or maybe you currently deploy it. There's a lot of different ways you can deploy Rancher out there, especially now that Rancher is running on Kubernetes itself. Full disclosure, I run a bunch of Kubernetes clusters even at home. I've got the classic 1.6 still running on a FreeNAS node. If any of you BSD folks are out there and you love that stuff. I also run some newer things. I actually had a lot of fun building the live demo because I was doing just brand new Kubernetes clusters all the time. So I'm assuming you've heard of all that stuff before. If not, then this is going to be a fun crash course into Rancher. I'm also assuming that you might have heard about Datadog. We're very, very big in the observability space. Not just in terms of size, but also we're very, very active in the open source community and kind of the community around observability in general. We've been contributors now to OpenTelemetry, which is a newer sort of up and coming standard, but Open Tracing, we've donated tracers for that. Even done some Open Census work and all that as well. Open Metrics, which we'll be talking about today. We're very, very involved with CNCF, which I'll also be talking a lot about today because CNCF is also a very, very large organization. So there are many flavors of Kubernetes out there. I wanted to just go over them because this is going to be framing kind of Kubernetes itself, where Rancher plays in this space, and why sort of observability within this space is an interesting sort of dilemma and all that stuff. So speaking of this whole thing, I'm going to start off by listing these flavors in order of difficulty. So the easiest one to start off with, and I'm going to go from like easiest to kind of hardest or most difficult to pull off. And then the first one I'm going to show off because I also want to congratulate Rancher for graduating their project into CNCF as a sandbox project. So K3S is going to be given to the CNCF, and it will kind of gain its own sort of life and sentience. And as far as I can tell, it's the first Kubernetes distribution to be under CNCF. So the aim of K3S, as they put it, is it's not as cute as K8s. It's still cute though because it's a smaller installation because they focus specifically on the IoT space and having a small, compact, ready to go standalone copy of Kubernetes that can run on really tiny environments. So you can build one on a Raspberry Pi. I happen to have one running behind me. You can't see me on camera, but it's in my office. I've got one of those running at the moment. They're actually a lot of fun to play with. So if you are interested in IoT stuff too, there is a up and coming conference that I don't think was mentioned at the top of the hour. So if you're interested in doing Kubernetes at the edge, with smaller embedded devices and things like that. Believe it or not, you probably can run Kubernetes on that too. And K3s is kind of one of those fun, easy flavors to get started with. You don't really need etcd, but as of the newer version of K3s, you can attach it to an etcd cluster. They were using SQLid or DQLid, that's right, which is supposed to be the sort of orchestration for doing highly available setups, but they've switched back to etcd. That'll be the new big change once they release that. So I'm super excited for it. If you haven't played with K3s, I super highly encourage you to go look at it. It's a really, really interesting variation. It's also used in KubeEdge. If you've heard about that from CNCF, it's based on K3s. So next is going to be the one I'm going to show off a ton today in the live demo. It's the Rancher Kubernetes engine, which pretty much happened as of the Rancher 2.0 release. They based everything off of Kubernetes as a sort of operator and sort of kind of bespoke packaged kind of setup of Kubernetes. And it's also, the nice thing is because if you're going with the Rancher flavor of the stuff, you get support from them because it's their distribution, their setup, their kind of viewpoint about how to run and operate Kubernetes. It comes with a bunch of different caveats, of course, because of how they do things. But I think in a lot of ways, it's by far the easiest way to get into Kubernetes, just because you'll have somewhat of an opinionated view about how Kubernetes should be run and operated. And again, like I said, you get out of the box support, which is not as easy to say for the next one that's a little bit harder to do. And I only say a little bit harder just because these are hosted managed clusters. So I'm talking about all the big ones out there: Google Kubernetes Engine, Azure Kubernetes Service, the Elastic Kubernetes Service, which is Amazon, so AWS, and then there's the one I won't be showing their service, but they do have one. It's DigitalOcean's Kubernetes Service, DKS. There's a whole lot of alphabet soup and acronyms here in this space. For the Azure side of things too, Datadog is actually we had to announce today that we'll be partnering with Microsoft Azure to be directly integrated into the platform. So we're pretty excited about that. We're actually building out an entire environment around it as well. So there's going to be a lot of interesting stuff coming in the future from them. And then, from all those hosted managed clusters, which are kind of easy, you go in there, you make your account, you kind of get a control plane ready to go. But there's some caveats with that. You can't really mess with the control plane too much. You get their sort of idea and flavor. The nice thing is you get their direct support. It's hosted. You don't have to worry about maintaining the cluster. There's upgrades. There's more options. You get integrations. You can probably operate it through things like Terraform and all that too. So you get a lot more sort of out-of-the-box automation, which is kind of nice. But again, you still have to bring a lot of things yourself to there. Now, Rancher can go on top of these services. So you can combine those two bullet points if you'd like. Where you can go into Rancher, spin up your server somewhere, and say in your office you can have a hosted server there, and then you can point it at your managed clusters, and it can just sort of help you manage them. So there's options that you get with Rancher in that regard. And then the last but not least, I'm going to say running your own Kubernetes cluster is by far the hardest. If we had this in a scale, I'd be putting it much farther down the slide because been there, done that, got the t-shirt and the extra set of gray hairs from it. You absolutely can run your own Kubernetes cluster. You're doing this with K3s in a way, but I would definitely recommend managing that with Rancher if you can, because running Kubernetes clusters is a little difficult, to say the least. You have to really keep an eye on your etcd, make sure that is up and running. You have to do a lot more to see what's going on, a lot more handful setups. Like, I would not recommend this for any small teams whatsoever getting into Kubernetes. I would always start with one of the first three options. Ideally, the two in the middle there are really, really good starting points, just because you'll have something that kind of guides you through most of the decision making, because Kubernetes is this vast ocean of choices and options once you get into it. And it can honestly feel pretty overwhelming. I will say, as someone who's still kind of learning every day what's new and different in Kubernetes and different environments and sort of setups you can do with it, that there is no real right answer for this. But as far as it's sort of universally thought about at this point, if you don't have a large enough team to manage your Kubernetes cluster alone, then it's not a good idea to try running your own unless there's some significant reasons for you to do so, such as heavy duty restrictions, or you have governmental things you have to concern yourself with, that sort of thing, in which case you got a lot of reading to do and you will likely break it a few more times before you really know what's happening. And that's where the observability side comes in. So speaking of observability, let's define what I mean about observability. So we're going to talk about observability and monitoring as concepts, and not necessarily that they're mutually exclusive. They're actually complementary to each other. So the observability itself applies to the systems that you run and how well you can understand their operation by gathering many facts of data about them. So I say observability is an adjective that describes the properties of your system. So it's a way to gather facts, know what's happening, and ideally, if you can observe it really well, you can predict what's about to happen. The more information you gather, the better. And now to go along with that is the monitoring side of things, which is more of the verb. It complements that by watching the state of your systems and communicating when they go out of bounds. So specifically any signals that the observability tells you that there's something not quite right or something you should be aware of. And it's not necessarily to say like this is an alert and you need to go on and troubleshoot the system immediately. Monitoring can act as a function of, say, like autoscaling if you're going to do something like that. You've probably heard of it, maybe you already do it, but if you can combine these two really well, monitoring can trigger your autoscaling groups because your monitoring is through observability, seeing what's going on in your system and letting you know what exactly is happening. But even then, it's letting those automated systems know what's happening so it can make decisions for you. That's where you get to kind of like the beautiful Zen area of Kubernetes, is when you can start mastering proper scaling with it and getting as much sort of saturation and distribution out of your systems. You know, I'm kind of already giving away some of the things I'm about to talk about here, but when you can master those two things, you can have one hell of a deployment on your hands, and also just deliver software very successfully to all of your customers. So speaking of observability and what I just mentioned there, let's define the world of observability in Kubernetes via the golden signals. If you don't know what those are, it comes from the Google Site Reliability Engineering book. If you haven't read it, highly recommend it. I'm not saying it's sort of gospel there, but it's pretty strong in terms of a way to look at the world of Kubernetes itself, because that's where it came from, was the Google side of things. So first, if you don't know all the golden signals or you just need a quick refresher, let's talk about latency, which is the time that it takes to serve any request. So the service specifically any request. This also applies to your Kubernetes cluster, such as the control plane, which affects your deployment. So latency can be not just your customer's experience of this, but if you also consider your internal development teams as customers. So if your developers can't deploy their pods and everything like that into your Kubernetes cluster at a reasonable fashion, or if for some reason latency is so high that the control plane stops functioning correctly, latency plays into that. So if you're not keeping an eye on that, that can absolutely affect you. And then speaking of that level of stuff, there's traffic, which is how much demand there is for a given service via sort of the network itself. This is usually HTTP requests per second and all that, because a lot of the different services from the Kubernetes world speak HTTP. This doesn't mean you can't serve other workloads on it, of course, but traffic is definitely sort of that throughput and sort of chatter that goes back and forth. This also counts for your etcd cluster. We'll be talking with each other very much to agree on a consensus in terms of what you got going on. This doesn't apply to K3s if you're doing an out-of-the-box install, because that uses a SQLite database instead, for simplicity's sake. And then everyone's favorite, sometimes my favorite or not so favorite, errors. This is the rate at which the requests are failing. And also errors kind of includes even the 200 OKs, because sometimes you can respond to a customer and not give them the entire bit of data that they were requesting. Maybe an internal service that provides the last half of that data request that comes back is down. So at the very least, if you're going to go for best effort, you can still give a 200 OK, but it's not completely fulfilled. So therefore, it's technically still an error that's going on in production. Or worse, if you get some kind of like false positive health report where the system says like, hey, I'm okay, but it really is not okay, right? Those are errors inside of your system. And then last but not least, and probably the most important signal of them all in the Kubernetes environment, is saturation. It's definitely the trickiest one to get right in Kubernetes because it's a double-edged sword. So saturation measures both the balance of how much system utilization, such as your CPU, I/O, memory usage, all that stuff, is being used or not used by a given resource or service. Because ideally in a Kubernetes environment, what you want is to have enough utilization of your system to where you're getting the most bang for your buck. Otherwise, you're effectively wasting a lot of resources in a way. Now, that's not to say that necessarily having an unutilized system is bad, especially if you're expecting large traffic spikes and things like that. I don't know what many of your traffic patterns are, but if you constantly have an ebb and flow of traffic, being prepared with that by mastering your saturation and being able to predict those ebbs and flows, and especially having autoscaling kind of like do your thing to bring it all the way up, and then when you don't need it anymore, tear it all back down. The more elastic and sort of resilient you can make that side of things with saturation as your guide, the better. That way you can really utilize your system as much. It's kind of like having a massive warehouse, but you're only using like a small little corner of it. But sometimes you might need the entire warehouse. You never know. That's what saturation is. But we'll talk a lot about that later on in the slides here. All right, so why does any of this matter? Why does observability matter? Well, if you're not observing your cluster really well, you just can't scale. I mean, you can, but good luck is all I'm going to say. You won't know where your limitations are in your system, or if you're about to hit the limitation. Last thing you want is to have a brand new site up, a Kubernetes cluster, and you're not paying enough attention to those signals, and suddenly you get posted on the front page of Reddit, or USA Today or CNN or something like that publishes a front page article about you, and suddenly you've got millions of hits soaking your services. And if you weren't keeping a good eye on scale beforehand, well, now you are, because you're down. So long and short of it there. You won't be able to react to outages or see them if you are not even be able to prevent them too. If you can't observe into your environment, how are you going to be able to provide a reliable service to everyone? Would you use a service that was down all the time? I know I probably wouldn't. I mean, I'm not saying it has to always have 5 nines uptime, but whenever you need it, is it there? Sure. If it's not, you're probably going to look elsewhere, right? So making sure that you have a good observability story is a big deal. Now, without a complete observability story, you won't be able to track down any bugs in production either. The customers or experiences, things like logs, traces, measurements that you take, various metrics, all that stuff. If you don't have a lot of that information, how are you going to know what's going on with the customer? Like they might give you a ticket that literally is like, I click a button and the thing doesn't work. And your devs will tell you, no, my code is perfect, which, that can happen. I know that sounds a little cliche, but, maybe they say their code is perfect, but there might be some other thing going on in your infrastructure that's making that code not execute the way that you thought it would. Because when it works on your local dev environment, you don't really have a lot of the production sort of environmental quirks that are messing with you. So the better you can keep an eye on all of the things that are talking to you, the better your developers can effectively find and track down those issues that end up out in production sometimes. And then here's the big one for me personally, especially since it's literally my job, but it ties into all of those previous ones. But observability should always facilitate better communication across teams in terms of building, maintaining, and delivering reliable software. You really can't do it if you aren't talking to each other, and especially if you aren't using observability as a way to communicate those things to other teams. Because you might be an SRE that is keeping stuff online. Your job is really just to make sure those deployments work correctly, and then if there's a problem, you can roll them back effectively and all that stuff. But what if there was a bad deploy? How are you going to communicate that back to the development team that had a bad deploy? There's some issue that didn't get caught in your CI/CD pipeline. It ended up in production anyway. We've already seen a couple bad deploys happen in the last couple of months here that took down entire organizations. There's lots of things that can do that, and without proper communication, you can't not only find those problems, or when they happen, be able to talk within your organization to track them down and recover as quickly as possible. So remember, we talked about in the sort of abstract beforehand, the mean time to recovery. That's a big deal, especially when you're talking about a Kubernetes cluster too. Like if there's any weird issues going on with your pods and stuff like that, being able to bounce back quickly is a very big deal. And observability absolutely supports that. So the great news I have about all this, because it might sound a little gloom and doomy, to track those golden signals out of the box with Rancher is pretty darn easy. I had a lot of fun setting up the demo and everything, which you will see very, very shortly here. There is point and click integration with things like Prometheus and Grafana. I'll definitely be showing that today in the demo. This also extends to the alerting functionality via Prometheus. So when you turn on that first one, you get the second one pretty much right out of the box. So you want to configure stuff right out of the immediately once you get up and running with your Rancher cluster. I'll point that stuff out to you, but for brevity sake, because you only have roughly an hour with you folks, I won't be able to show you all the cool things it can do. I kind of wanted to just go from a kind of out of the box and show what is out there in the observability space and kind of what you get immediately from there and what Rancher will help support with you. The Rancher dashboard also integrates into this. You'll get to see the dashboard kind of come to life, and like props to Rancher for how awesome that whole experience and story is. I will show that off, of course, in the demo, but Rancher dashboard directly integrates with those things. It gives you easy access to your Grafana dashboards and all that other stuff, so you can look at it immediately. You can see what's happening there. And it doesn't hold your hand too much through that process, but it does give you a lot of stuff that's immediately there out of the box that are great sensible defaults to get going from. And if you want to be gathering aggregated logs from your pods and your applications and all that stuff, there's point and click setup for that too. I won't be covering that in the demo. I can go over it if you folks ask me to show you where that stuff is and kind of what your options are. But we're going to be talking about observability more in the specific parts of the golden signals when it comes to things like Prometheus, which is gathering metrics and health data that's going on inside of your sort of infrastructure. And then the last big reason to stick with this too is you get support when you need it. So if you go with the full support route from Rancher, you have their support and help. So I highly recommend that for the folks that are fairly new to Kubernetes, or maybe you're a little bit more mature in it, but you want to take it maybe to the next level. Would highly recommend that you reach out to them and sort of talk with them about your setup and kind of ways you can do much better about looking at what's going on and how you can gain even more out of your environment with them. And that support goes both ways because we are Rancher partners as Datadog. So if you decide to, if you got the whole Prometheus setup and everything like that, and you want to start adding Datadog to it, there'd be support on both sides from us. So if you reach out to us, you can say that you've got a Rancher environment, we'll know what you're talking about, but if you also get stuck there, we can also help reach out to Rancher and figure out what is going on there. So let's talk about a little bit more in the observability space here before I get into everything, because I want to provide a lot more context about the Prometheus and Grafana and even like where Datadog kind of fits in a lot of this stuff here too. Is that the landscape is shifting constantly. As I built this slide deck, 2 of the slides actually had to change because there was newer stuff in there, like I said, the K3S thing and all that, so I had to shift things around. Kubernetes is this constantly moving target. Not to say that it's necessarily bad, it's actually great to see all of the sort of contribution and movement in the space, especially when it comes to observability too. A lot of companies are moving to these larger, more complex deployments, and there's a bigger and bigger push to make sure that you can keep those things working and online. So there's a massive push for the observability space from a lot of different companies, including my own, that are all trying to make this a lot better for everyone. So Prometheus is more than just metric collection now. Prometheus has kind of morphed into that. And honestly, when I first got into this space and stayed kind of in it in the last few years too, a big misconception I had was like Prometheus was kind of like the one and only option you had with Kubernetes because it was the big sort of blessed one. It's a CNCF project, right? It's got all that stuff there. But Prometheus has kind of morphed into more than that in the most recent changes here. And if you're going to be running Prometheus these days now, given that Prometheus is only just kind of like the single cluster, you really want to aim for something more high availability now. So there's Thanos, which is now really maturing as a project. So if you are already running Prometheus, you absolutely should be looking at Thanos if you're going to stick with Prometheus for the long haul. And the reason I say that is just because you want to have more than one copy of Prometheus. It's kind of like who's watching the watchers type thing, but also just if you don't have your observability system in place, how will you know stuff is working? Like your observability systems should have better reliability than even your production environment, because if it's down, how will you know production is down? or is production even still functioning? I mean, you can have someone clicking through your website, but that's not a good automated way to know if something's wrong at 2 in the morning, right? So I would highly recommend you check out Thanos for something a bit more stronger and resilient. It's an interesting project. I haven't played with it as much lately, but by all means, check it out. And then because of the maturity of Prometheus itself, and this is where I started getting confused because Prometheus ultimately became kind of the de facto format for exposing information about your services within your Kubernetes cluster. So that has kind of matured and it became the base of what is now known as open metrics. And pretty much every CNCF project out there is moving to or has already moved to open metrics. So if you haven't done that yet within your own projects internally, so all of your services that are deployed, et cetera, if you start following the open metric standards, you get a lot out of the box already with Prometheus, which is there. So if you haven't been looking into that, I would, after this class, go look at it, play around with it, see what you get out of the box. So like if you deploy something like Traefik, for example, or something like that, you get open metrics immediately. So you don't need to worry about configuring a Prometheus exporter, et cetera. The service just speaks open metrics already, which is ideally where things should really be heading, because that is sort of where you have some issues with setting that sort of stuff up. So speaking of that and setting things up, you don't really get everything for free when it comes to open source, unless your actual use case matches a specific story in open source and someone has shared how they got through that story. Very unlikely, but there's going to be some assembly required, kind of like IKEA furniture. When you get it, you gotta build it yourself, right? And it always looks really cool in those diagrams, but there's always going to be some weird thing that looks weird or looks kind of interesting in the diagram, and then you get through it and you're like, oh man, I missed this like little keyhole for the screw or something like that. And it's not necessarily the end of the world, but you will get frustrated, right? So in order to make those dashboards in Grafana, you need to learn a whole new language. You need to learn PromQL, which is not too hard to learn necessarily, but if you're going to be building any dashboards or alerting, you're going to need to learn that. There is a bunch of stuff already there, so I would highly encourage you when you set up those default dashboards inside of Rancher, and use the point and click installs. Dig into everything, all the queries that are going on behind it. I'll show you how to peek behind that curtain. It could be a good way for you to learn some example queries and play around with them, break them. By the way, I highly recommend you just do this on like not production, do this on your own sort of dev clusters, or if your company has like some variations of staging, or honestly, you can just run these locally in your own system. You can spin up K3s clusters or just go into another cloud and give them a shot. Hopefully you've got some other separate environments to try them, but play around with PromQL, but that's something you definitely need to learn in order to do anything more effective with it. The other thing too is anything not providing open metrics already needs a Prometheus exporter of some kind in order for Prometheus to know what's going on with it. So you need to build an exporter, deploy that in, ideally as a sidecar that goes with the service that Prometheus will be talking to be like, okay, I need to know what's going on with your pod. Is it healthy? What are the stats? What's it doing? And all that stuff. Like there's different metrics you can expose, which will get aggregated into Prometheus for you. But this is where I was talking before, kind of, hardcore about open metrics. If you can just get them to speak that immediately, don't need it. So that will actually help you a lot in your initial journey as well. And then finally, you need to, the big thing to keep in mind here is that there's a maintenance cost for maintaining these clusters. So when you start up your Prometheus and Grafana clusters, you get them, really cool immediately out of the box. You can choose where those get deployed with Rancher, multiple copies of them. But by definition, your observability systems need to be way more available. Like I was talking about before with the Thanos thing, if it's not available, then how do you know what's going on with your infrastructure at all? And then you'll also need to allocate, human resource time to maintaining and sort of building or expanding those clusters. Because as your infrastructure expands, that's going to put a newer, bigger strain on all of your observability stuff. Because we're talking about Prometheus and Grafana here. So if you've got storage claims and stuff to manage longer-term storage of a lot of your metrics, because if you, restart those systems without having any sort of storage for them, then they'll just wipe out all the histories. So you won't know if this CPU spike is a thing that happens regularly, like maybe it's weekly or daily, which can point to a problem in your infrastructure, or is it something that's brand new and you need to keep a closer eye on it? So maintaining those comes with a significant human cost. So you really have to think about that with everything else. Like there is, yes, the monetary cost of spinning up additional resources and servers, but there's also humans that have to operate this. So where does Datadog fit into all this? And this is the one time I will talk about Datadog before I jump into the demo, and then I will talk about Datadog near the end of it, of course. But where does Datadog fit into this whole thing? Because, like I said, we're in the observability space of this whole puzzle with Kubernetes. You can install Datadog alongside your Prometheus, but ultimately it can replace it. And the only reason I say that is just because Prometheus and Datadog kind of function similarly in what they do. Datadog can collect a whole lot more, so Datadog can function as not just Prometheus and Grafana, but it can also function as your Elasticsearch cluster for your Elk stack to take in your logs, etc. It can also be your Jaeger cluster, which takes in all of your traces to see how your applications are performing for each of the tasks that they do. There's lots and lots of things that it can do, which simplifies that story. So if you are going to go towards Datadog, there is a sort of migration path you can take, so you don't need to just immediately replace it, but you can definitely allocate the resources to get the agent in, just like you would with Prometheus and all that stuff, to build your cluster and run it. And then ultimately you can replace it, or you can run them side by side to see which one you like more. But ideally, you should really have one place where a lot of that stuff comes in. Out of the box, you get a lot more details about your cluster than Prometheus and Grafana give you right off the bat. I'll show you a lot of that stuff in the demo, so you'll see kind of like what you get immediately and a lot of what you really should be keeping an eye on to maintain those golden signals. There's a lot more that's there, but again, for brevity's sake, I'm cutting a lot of that down, so I'll answer what I can with your questions. And because Datadog brings all those metrics into one single place, you can track all those golden signals more effectively. So when you combine, like I said, those logs, looking at the process monitoring, networking stats, all of those, there's a lot more that you can gather with Datadog these days than just what like Prometheus and all that can do. Now, Prometheus can do a lot of the stuff that I'm mentioning here, things like the process monitoring, all that stuff, but again, you need to build a smarter exporter for that, or if it's your own service, you need to expose a lot more of that through open metrics. But if you want to get things like traces and all that, this is where you need a tracing exporter and a Jaeger cluster to pull that in. So that way you can also have that, but now you have Jaeger to look at, plus you have your Grafana dashboard to look at, so you can look at traces that, like it becomes more than one system. So in case it's a problem, having everything kind of all in one place that you can move effortlessly between each of the bits of information that you're getting from your observability system makes a lot more sense and allows you to get into the specifics of what's causing that problem. And as I mentioned earlier, it is much simpler to run something like Datadog or any of the other options, honestly, that are out there. I'm going to talk about Datadog because that's who I'm here on behalf of. But it's simpler to run Datadog than a combo of that Prometheus or Thanos plus Grafana plus Elasticsearch plus Jaeger. Now, when you think about that, there's a lot of things that are basically going to be taking away significant amounts of resources within your cluster. And you also have to have engineers who are managing and monitoring all of those, because if any one of those systems goes down, you've lost part of your observability story. So now at that point, you don't really know the entire story of what happens if a break occurs, or if you have a bad deploy, and maybe some of the customers are noticing it. When you have it in one central place, you can have one place that sends out those alerts and monitors. You have one place where you can look for all the information. It simplifies that story significantly. So doing something like that, where you have one versus all of these, drastically reduces your overall like actual cost of running it in your cluster, but also the human cost of having to manage all of those tools at once and or sort of rebuild them in kind of the image that you see, versus getting something that's a bit more kind of off the shelf and can even be sort of tailored to your environment. So let's get on with the show. This is the live demo portion now, so let's see if I can get there. And then while I'm setting this up too, we can go through some questions if you folks have them. Looks like there's already one up there, and I will try to get to that in a second here. But first, I got to run some Terraform here. All right, There we go. So to show you this is a real true live demo, I am spinning up Terraform here. And this is my DigitalOcean project that I've got going. I've been doing a lot of setup and teardown here, so you kind of watch the magic of the quick start. So to give you kind of full disclosure of what I'm doing and how it's not super magical of what I'm doing here, I'm using the quick start that is in the Rancher documentation. So it's easier for you to follow along if you want to do this yourself. Even right now, I won't be offended if you're going to be like having some fun with Rancher Kubernetes while we're on this call. But I'm only doing a couple of tweaks to the TFRs there, and I'm applying it. So I'm spinning up a cluster in the MYC3 region. There it goes. It's doing this. It's going to take about 5 to 7-ish minutes, give or take, is what I clocked it at. So this is where we can take some questions in the meantime while it spins up. And then I can show you what I'll be deploying into there as well. So let's see here. So we got, okay, so there's a question here. How about OpenShift? Yes, so OpenShift is another thing in this space. I won't be talking about it in particular. We can observe it on the Datadog side, so can Prometheus in a way. You can, with OpenShift in particular, I would actually wonder, like, because yours is kind of a more of an open-ended question. Are you wondering about OpenShift as in like how that works in the observability space in particular, or what does Rancher do in there or whatnot? It's a little open-ended. If you want to get more specific, by all means, ask that question again and let me know. I'm kind of curious, like what in particular you want to know about OpenShift. In full disclosure, I've got not a ton of experience in OpenShift. I play with it here and there. I know folks in the OpenShift space. So for some of the more like specific questions there, let's see here. Here we go. The OpenShift was kind of missing from the comparison chart and started slides. Gotcha. Okay, so as far as those options, I'm talking more. So with my slides, yes, for full disclosure, there, I'm talking more about the specifically like the Kubernetes official space in a way. So Kubernetes and any sort of derivatives and offshoots of that, and OpenShift definitely is in this area in terms of orchestration and all that stuff goes. I left it out kind of on purpose, and not to be like, I'm not trying to downplay OpenShift in particular. I'm just focusing more on kind of the CNCF side and sort of the open source end of like Kubernetes and kind of the things that kind of work immediately out of the box with it. So I'm not trying to downplay OpenShift. It is another option. I'm just not going to cover it today. So sorry, so it's not like a super complete answer there. Hopefully that does work with your question. If not, then I would love to hear more offline about kind of what your story is with OpenShift there, and I would love to like talk with you about it more. Because I am really curious to see like what sort of folks are doing with OpenShift and all of that. I know what a lot of my friends in kind of the developer relations space are doing around OpenShift, but I'm curious to know what your use cases around OpenShift. But very good question though. Still good, important thing to bring up. Still got the build here. As per Rancher documentation, OpenShift cluster management via Rancher is supported, but not tested by Rancher. There you go. Good point. Yes. So if we're talking about Rancher in particular, yeah, you can do it. Would not recommend it necessarily, but worth giving a try. And especially if it's something, if you're already a Rancher customer, you probably should be talking with Rancher about that. So in case there's any issues, you get the support from them, and they can kind of learn about your use case as well. So I'm not sure where all that stuff lands with SUSE buying them, but I'm not going to speak to that since I'm not part of Rancher. I'll let Rancher answer that question.
For I apologize. Which of the questions?
For the OpenShift question, because there's one asking about OpenShift in particular. And I was giving sort of my answer about it, but then there was another response about Rancher not fully supporting OpenShift yet, so I didn't want to speak to that unless folks wanted to chime in.
I see here. OpenShift cluster management via Rancher is supported but not tested by Rancher. I personally cannot answer that question, but I can find out for you. So can follow up if you want to. Just stay tuned to our Slack channel. We can. I'll do some research on that.
Yeah, so if you got any like Rancher specific questions, I'll answer what I know about Rancher, but I will definitely defer to them because it's their thing, not my thing. Still love Rancher though. It's a really nice, easy to set up thing. So as you can see here, it's still getting there. It is now provisioned one sort of kind of half of the cluster. It's almost there. If you haven't played with this before, the quick start is actually really neat. It gives you kind of a lot out of the box. So okay, here we go. Got a lot more questions now. All right, they're flowing in. So is with monitoring features and dashboards, alerts, and all that kind of stuff? You are very correct. There's a lot that I'll go over some of that near the end of the demo, so you can kind of see where Datadog fits into the space. So yeah, Datadog originally started as kind of what would look a lot like Prometheus and Grafana, where it was specifically tracking just metrics. But it has grown over the years into a much more complete observability tool. And by that, I mean it not only collects the metrics and information about sort of the statistics of what's happening inside of your cluster, but now it can collect the traces from within your application. We've now deployed profiling, so you can see not just the sort of timing of how each of the sort of functions and methods inside of your applications have gone, and how, what sort of allocations and resources they're taking. So if you are wondering why your pod is sucking up a ton of CPU, that is a way you can answer that with the application performance monitoring. There's also network monitoring, so you can really keep an eye on that traffic and sort of saturation question in terms of how that goes. We definitely do log collection now, so you can correlate a lot of sort of the output and the debug information that comes into those logs, because those are actually pretty valuable. So because you can attach a lot of the data into the metrics that come out and give it some more metadata, but that makes your metrics pretty heavy. But if you include that in log data, and you include stuff like for traces, if you include the trace ID, you can do what's called distributed tracing. So if you've never heard of that before, by all means, go check that out. That also gets integrated into the Datadog dashboard. We have now launched, as of Dash, there is a sort of incident tool. So in case you are having issues or outages, you can track all those. There is also the user end of things called real user monitoring. So if you want to know sort of what's going on with sort of a lot of the front end in JavaScript, because my guess is many of you folks might be deploying a bunch of that stuff. So this will allow you to see kind of the performance side of that stuff and how that goes all the way into your Kubernetes clusters and affects everything else in terms of your service. It's a really, really heavily fully featured tool, to say the least. It sounds pretty overwhelming. There's a lot of options. You don't have to use them all. You can always start with just something really small and basic and move your way up there. It's kind of as you need or what you need. So hopefully that answers that question there. It's a pretty long-winded answer. All right, I will start answering a couple more questions, then I get right onto the demo here. And that looks like I've got my cluster up and running. Yep, got my 2 nodes there. So I'm going to pull this up in the browser here. So I got a brand new Rancher cluster. I'm not going to tell you to log in, so you can't be messing with my stuff, but you can pull up the app that I will be deploying into here pretty shortly. I got my login and my super sophisticated password. No, it's not 1234. See if I can remember it. There we go. Type that in wrong. Fudge the numbers. Anyway, so let's see here. Did I hear correctly that you said you recommend using out-of-the-box Prometheus Grafana when first starting out? Yeah, actually, I would really like, especially if you're going to be starting out with Rancher and all that. The sort of really easy method to get going. If you aren't aware of Datadog, or you're not sure if you're going to go with Datadog yet, or maybe you have some other constraints or budget or something like that. I mean, granted, we do have a 14-day free trial you can start with if you want to get off the ground there. But it's a good place to get going with that, especially if you are going to end up using a lot more sort of the open source side of tools. Datadog is mostly open source. I say mostly as in like our agent and everything else that is collecting information is all open source. You contribute a lot of the stuff we use internally to open source projects. So things like Kafka Kit and all that, because we run Kafka at kind of ridiculous scale. We're talking like trillions of data points per second. So if you want to see how to do Kafka in like the most hilariously like large scale that I can still barely wrap my head around, we do a whole series called Datadog On, which I would look up after the call here. Those are free online workshops, not workshops, sorry, they're free online presentations, but you can also ask questions of our engineers and learn how we run this stuff at very large scale. Because if you ever wanted to know, Datadog does dog food. Not going to excuse that pun, but we do dog food our own product. So we use Datadog to watch Datadog, which sounds weird and kind of like Ouroboros type thing going on, but we do that. So if you're really curious, that's a really good thing I would suggest. But we're going to go with the story of you're going to start off right off the bat. So let's get into this here, and I will get to more questions near the end or when we got like sort of a lull or break while we're waiting for stuff. So, but keep the questions rolling in. There's a lot more now. Wow, great, thank you. I'm loving this participation. This is my Rancher cluster. It's cute. It's brand new. It just finished provisioning, so it's up and running. So if I go clicking around here, so you get a couple of clusters off the bat with the quick start. I'm not going to go into the DO custom one. I'm just going to look at local for the time being, just because this is kind of the node that I'm going to focus a lot of my attention on. So when I click into there, I get kind of this plain Jane dashboard. It's great.
Hey,
It's not
Aaron.
bad. Yeah.
Aaron, quick,
What's
sorry to
up?
interrupt. Just a couple people were asking if you could increase the size of the text on this Rancher dashboard screen,
Oh, sure. Yeah. Does
just to make it a
that
little
should hopefully
clearer.
work a little bit
Yeah,
better.
that's great.
Yeah,
Thank you
sorry
so
about that.
much.
I forgot to reset my view.
All good.
All right, hopefully folks can read that now. Thank you. All right, so yeah, so this is the plain Jane dashboard you get. Like this is what I had before. So this is where I was looking at my global views. These are my clusters that have been deployed right off the bat. So this is brand new, just got started. This is a 4 CPU system with about 8 gigabytes of memory. The information you see like right off the bat is just some basic monitoring that Rancher is already looking at immediately with its agents, because Rancher has its own set of stuff that gets deployed. The way you can kind of peek behind the curtain is if you go into the local menu up top here and you go to System. This is where you can kind of take a look at sort of everything that comes with the Rancher ecosystem. Because Rancher has, if you were an old school Rancher user, kind of like I am, and you've used the original one they called it cattle, which is like their sort of variation of what we now would call like pods and things like that, or even just like the orchestrators or the control planes and things like that. So that was kind of their whole sort of setup to manage and orchestrate all of your workloads that are in a environment. So they kind of move that translation into the Kubernetes equivalent. So you can see all the different stuff that's running that kind of just comes right out of the box. It starts with Canal for the service mesh and all that stuff. I know there's just a masterclass in service meshes. That's an entire set of talks. That could be a whole week-long course about that stuff. Not going to get in that today. We're going to talk a little bit about just how to keep an eye on some of these things. But this is, where you can kind of see what's happening behind the curtain. And then we got the default cluster, which is currently empty. There's nothing deployed into it just yet. So let me light that up. And then while we're doing that, we're going to deploy everything else too. So I'm going to go ahead and do a couple things here. I'm going to apply some already baked Kubernetes configurations. These are, I will show you in a second here, from an open source project that my team helps maintain, just as kind of a fun demo app that you can play around with. And kind of to show the observability story as it comes with Datadog. So I'm going to go ahead and apply all of these into the Kubernetes cluster. And you will see immediately, there it is, bam. It's kind of like magic when you get to see this stuff like happen kind of in real time. It's just, that's fine. These are okay. It's starting to update. There we go. It's just pulling the images now, getting them spun up, getting the pods ready, and then waiting for the pod to be in a ready state. It's kind of fast, amazing how fast this happens now. So the app I'm deploying, for full disclosure here, let me blow this up. So this is the e-commerce workshop app. You can go check it out if you want to. It is a Ruby on Rails app with a free commerce add-on. So when it is up and running, you will see something like this. If you are paying attention here, the IP that it will be is actually this cluster. So let's see, it'll take a second for it to initially pull up because it's got to warm up. Even within the pod, it's got to build some caches initially before it starts answering requests. We'll see, like here, we got 93 folks in here. I'm not sure if this will scale to the amount of load that you folks will throw into it, but let's give it a shot. This is demo time, so we'll see if it works or not. Hopefully it does. Come on. I know I sacrificed something to the demo gods earlier today, so hopefully they will be good to me. Speaking of which, let's go check out. Yep, we got our ingress controller, so that's good there. So let's just peek behind the curtain and see if we got an ingress controller that will let us talk to this cluster. All right, it did make a liar out of me. It's got everything spun up. So yes, this is the app that I just deployed really quickly. And it's got several services within it. It's got the front end that you're looking at here. And it's a Ruby on Rails and a Spree Commerce add-on app. And then under the covers, there's a database that they share along with a advertisement service, which is this right here. These really cool looking bags. And then we also have a discount service that it talks to separately. These are both written in Python. They both talk to this, and it's kind of our way to show like what a basic sort of microservice setup would look like. I still have to build a nicer Helm chart for it. Haven't done that yet, but I will not long after this Rancher webinar. It's something I'm working on. But you can go clicking around here, look at the different items and stuff. There's nothing you can really buy here, but this is just something that you can deploy, look at, play with, that will generate some metrics inside of here. So let's go back to looking at the resources themselves. So I'm going to go back to local here, look at the active cluster. So we can see here that we got a little bit of CPU memory usage now. We've got more pods deployed, but it's not really telling us a whole lot. So let's go to looking at, let's see here. There's a little link up here at the right here, enable monitoring to see live metrics. Now there's two different ways to get to this, but this is kind of a nice little hint to be like, hey, if you want to see some more real-time information here, there's an easy thing you can turn on. If you go into the tools menu here, you can also go to monitoring. So I can go there from here. If I go back and I click on that same link over here, it takes me to the same spot. So this is for monitoring this entire cluster, so the whole local cluster, not the defaults. So there's clusters and projects. I'll go over that in a second here inside of Rancher. So if you don't know that concept, I'll explain it really quickly. But I'm going to turn on just the basic cluster monitoring. I'm going to turn on the node exporter to give me some data and information about the node itself. So that way I know a little bit more about the health metrics of what's running my Kubernetes cluster itself. I'm going to leave the persistent storage off for both Grafana and Prometheus. One for brevity of the demo, and also just because like I'm not going to go too much into depth about the storage claim side of things. You can ask some questions about that, but I'm not going to go too much into depth of it. Again, just to keep things a bit shorter today. So I wanted to show you kind of what's out of the box. So if you just enable it without getting any storage, which is still not a bad initial approach, because if you haven't learned about how storage works inside of Kubernetes, it's a good place to start. Granted, it won't save your information. It's a good place to at least start having some observability inside of your infrastructure. You can always add it later. It doesn't have to be like an all or nothing approach. So you can hit enable down here. And this is where we get to kind of watch the fun magic happening. So this is where it's enabled. I'm going to go back into the local cluster here. So now you notice that link has changed. Now it's red text. This monitoring API is not ready. Now this is where the fun magic, like this is not even going to be a TV magic thing. This is going to be just kind of like magic on the screen. But I'll answer another question or so while this is going. But keep an eye on this screen here, because this is about to shift right before your eyes. I'm not even going to refresh the page and leave it as is. This is kind of the fun, mind-blowing moment for me when I first started, messing with this initially and kind of like doing the Terraform applies and all that stuff. Just how easy it was to just like immediately have something useful. And you already see the spike happening because it's spinning up the pods for Prometheus and Grafana. Those are all getting spun up into the background. I'll show you what they look like in a second, but I really want to show you this bit here because I think it's really cool. Let's see here. So is there a Datadog Rancher integration in the works? Were you able to enable Datadog through Rancher UI and have DD daemon set deployed automatically? You will see that soon. So I will answer your question by showing you. So we'll get to that. Thank you for the question. Let's see here. What is a DigitalOcean droplet? So DigitalOcean droplet is basically a miniature VM, no different than your EC2 instance or your Azure instance or anything like that. DigitalOcean calls them droplets because it fits in the motif of their naming. It totally works with the naming scheme. So if you ever hear droplet, that's what I'm talking about. That is not to say that Rancher can't deploy onto the DigitalOcean Kubernetes engine. So you can go that route. But there, I don't think they use the terminology of droplets at all. You just have a cluster size. So that's a different thing altogether. But if you're going to run like actual VMs, those are your droplets basically. Let's see here. Can I observe, monitor microservices using Datadog? Absolutely. You very much can. You can look at the connections between them. So if you enable the tracing and things like that, especially distributed tracing, you can kind of draw the relationships. There we go. Here comes the first thing. So notice now there's a new icon. If you are familiar with Grafana, you'll know that's the Grafana logo. If not, then, well, you got the legend right here. I'll show you what that looks like in a second here, because there's a second magical thing that will happen that takes about a minute or so to show up. But you'll see if you can notice the change. Let's see here. But yeah, I can talk a little bit about that as far as observing and monitoring microservices. Let's see here. How do you grab app metrics and send a Datadog? I will also talk about that in the demo a little bit later on, so we'll get to that. I'm going to show more of the open source side of things before I get to Datadog itself. All right, there we go. So now you notice there's a little bit different stuff going on here. So this is what I want to focus on for a good hot minute, because this is where I want to talk about the things you need to keep a really close eye on when you're going to be managing your Kubernetes clusters. I'm going to be focusing on one particular cluster. But when you zoom out across clusters, there's a different sort of thing there. But ideally, you want to like focus on any given cluster to get started. And so right off the bat, we get these newer sort of dials. Instead of it being just blue, now it's blue and green. And what do those mean and all that stuff? So if you're new to some of the concepts in Kubernetes, this should hopefully put it into reference. So let me pull up my notes here to make sure I'm on task with this stuff. So the thing we want to talk about is the blue versus green, especially in the CPU memory as far as they're concerned. So blue is what your reservations are. So this is where you tell Kubernetes, like, sort of a minimum set or the things that you want to specifically enforce for the orchestration side of things. So I don't have any of those bounds. So truth be told, like when I applied these different YAML files, none of them had specific requirements necessarily, other than please run at least one copy of this service. So that's where some, but none of them really specify like I need this much CPU or anything like that. So for now, it's just guessing that these things need a certain amount of CPU. There's a little bit that you can tailor back and forth on that side of it, but this is where you play around with that particular lever. Now, just because you don't have them bound or specifically allocated doesn't mean you can't exhaust it. When it comes to the reservation side of things, there's two specific levels that you want to control that I'm not showing you here that are kind of combined in with this. There's the kube level, and then there's the system level. So kube is to control the allocations around the kube system daemon. So like kubelet, container runtime, stuff like that. All the things that Kubernetes makes, well, what makes Kubernetes Kubernetes. So a lot of those are kind of really, heavily protected system resources that you kind of want to make sure you allocate to above your services, because without them, your services can't really get scheduled effectively, or you can't, sort of manage your Kubernetes cluster effectively that way. The second one is system, which is even more critical in my opinion, because that controls the allocations around your system daemons like SSHD, your UDEV stuff, even your user login memory and CPU is allocated that way. And in fact, in Kube 1.17, I believe, 1.17, you can guarantee CPU at the system level. So that way you don't do what I've done before in the past, where you over allocate CPU and suddenly you can't SSH into your node. Been there, done that, got that t-shirt. It is actually possible to do in Kubernetes, because when you give it an unbound sort of free reign over your system, it will gladly eat your system alive, because it's doing its best to allocate as much of your system as it can. There's a lot easier stuff out of the box where it tries not to do that as much anymore, but older Kubernetes was not as friendly about that stuff in the past. So it's definitely something to keep an eye on. So again, like I said, just because there's no limits in the system does not mean the control plane won't start terminating and kicking your pods out of your cluster because there's no resources it can allocate. So if it sees that your pod requires a specific amount of resources and there's too many reservations, it just won't allocate it. Or if there's not there's no reservations holding it back, but your CPU is already pegged, well, probably not going to be there, or it's going to start kicking other stuff out to bring that back into balance. And you can tune how aggressively it does that, but out of the box, it will do it somewhat aggressively, to say the least. And then green is, you can obviously see, is sort of your active usage on both sides. So this is where you can see exactly how much is being used. Not quite at any given time, this still has a lag. So even this dashboard, which is now a lot more useful in terms of telling you the state of things in your cluster, it doesn't tell you sort of the complete story or kind of the history. And that's where we're going to get into looking at Grafana. And then over here on the right, I glossed over pods, just because you have a specific amount of pods up there. You can change this, you can tune this. This I generally tune dead last, and that's only if you really need to like limit the amount of things running in your cluster. Because remember, a pod is also a combination of a bunch of containers. So you can have a pod that is huge, with bunches and bunches of stuff in it, which means they're really expensive to run inside your cluster. But you can also take the approach of having your pods be as small as possible. Absolutely, you can sidecar everything in there. You can put a Prometheus exporter, you can throw a Datadog agent in there, you can throw in a logging exporter like FluentD or something like that. But that makes your pods bigger and bigger and bigger. So then if you start allocating each of these pods, so when it goes to an allocate, it's going to take up a bigger chunk in CPU of memory, or CPU and memory, because it has to spin up new copies within those pods. So you're duplicating a lot of effort and resources. So this is where some folks tend to go towards services versus just sidecars within the pod. And there's reasons you do or not do that. And again, that's a lot to do with your resources. So this is why your observability game has to be really good before you can kind of make those sort of decisions. And it's a balancing act that you got to do pretty much all the time. And it shifts as your developers shift with this stuff. So without further ado, let's get into Grafana. So I just clicked on that link off to the right, that little bouncy logo here, and there's my Grafana. So here's your default Grafana dashboard. Well, not dashboard, this is your kind of greeting screen. But if I click up here at the top left, I'm going to blow this up a little bit so folks can see it better. There we go. That should hopefully be better. Got to make sure you folks can see that here. So I'm going to hit home, and then so these are a bunch of them that are here. I'm not going to go into Istio. That again can be its own masterclass. I think it is or will be soon. I'm going to go over some of the big ones you kind of want to watch. So let me make sure I'm checking on my notes here. So there we go. All right. So we're going to look at the cluster dashboard first. So these are all kind of baked up for you out of the box. So you don't have to think about them. You don't have to learn PromQL to do them. They're kind of baked and built for you by Rancher when it spins everything up for you. So when you go into cluster, this is where you can see everything going on within my cluster. So you can look at the CPU usage. It's very much like this. It looks super familiar, right? Except for the file system usage. It's not pods, but these are kind of the main things you want to look at for a particular cluster, and the things you got to balance and look at. So especially when it gets to the orange or red line here, not great. That this is the way that Kubernetes kind of divides and conquers for your system resources and what it's doing, right? So the bigger things you want to keep an eye on, and because one thing you will notice here too, Rancher puts into context what your reservations are here. Notice so you don't get that out of the box with Grafana. You can still look down further into the other dashboards to kind of correlate the two together. You're gonna have to stitch those things together if you want to overlay one over the other to kind of get the same sort of look and feel. But the nice thing is because there's out of the box integration inside of Rancher, where it's already talking to Prometheus and saying like, what do you know that I can show right now? It's like, okay, all of the services I need to run a Kubernetes cluster up and running, everything's great. And then I can show you kind of why at a glance. This is a good place, like especially if you're getting some kind of alert, you can immediately jump into this to kind of get maybe a little bit of information right off the bat before you jump into Grafana, unless you go straight into it from here. So the ones I want to focus on in particular, let me pull up here. So I've got it scripted here that I'm running through. So I want to talk about a few different things. So we're going to talk about, we'll look at some of the stuff like the node information, but that's not going to be super useful right off the bat. But we're going to go straight into containers and network I/O pressure. So containers running, this you can get a much more detailed look at, let's say inside of Datadog. I'll show you a little bit of that later on. But this is an interesting one to watch on occasion to see what your overall load is, because again, when you think of things as pods, they're groupings of containers. So if you start seeing a large number of containers running, but then if you're over here, be like, but there's only like 10 pods, why are there 100 containers? That's an interesting thing to look at and be like, okay, we need to maybe review how much stuff we're sidecarring into our pods, because that is a very big temptation. I started doing that stuff as we look at these two side by side. I see like pods running versus containers running. If this number is really low and this number is super high, that can be an indicator of a problem. Because you might be overloading or oversaturating just the pods themselves. If they're too big to move, then your Kubernetes can't move them for you. Because Kubernetes will try to balance your system, also given how you tell it to, because you can give it specific affinities to be like, I want these pods to always be on this node. And it can do that for you. But if you give it free choice across all of your nodes inside of your cluster, then it will try to move them to where they can best perform. So it will spin up a new one, tear down the old one. But if it's doing that constantly, if you're starting to see a lot of churn going on with your systems, this is a place I would start looking. Is like, are we doing pretty good about that stuff? Because like, especially if you're in the SRE side and you're not looking directly at sort of how the deployments are working, this would be a way for you to start having a conversation with the developers about like, let's talk about pods and containers. That'd be a good place to do it. Like, do it in a friendly manner. Don't have to get pressure on them like that. So next I want to look at is network pressure, because I'm going to look at this as kind of the general graph before we go into like the specific network side of those things. So this is where we see the combined network IO pressure, and this is where we talk about that traffic signal that we're looking at. So this is where we just look at the total inbound and outbound. And if we start seeing larger spikes in one way or the other, because the sort of lower bound here is all the sent traffic, and the upper bound up here is the received traffic. So if the top one spikes, it means you're probably getting a lot of incoming requests. It can also mean that someone is running a crazy script and they're hammering your control plane. So there's a lot of symptoms or a lot of problems that can create that symptom. Similar on the outbound side, if someone snuck in a bad actor pod into your stuff, so because that's possible too. This is why there's things like CIS scans and companies like Sneak, SN1K, I can't always pronounce it, but they do security scans of your pods and things like that, or your containers. Make sure you're not accidentally pulling in a bad actor on your containers. Like there might be some vulnerabilities getting taken advantage of, so you might see your sent spike out because someone's running a Bitcoin miner or a DDoS agent or something like that. This is where you'll see those things happen. And if you're not sure, if you start seeing that spike occur, this is where you want to start drilling down into either your pods, your containers, or even your processes. So if you go into the pods network IO, now you get to see it broken out across pods. So this is where you can kind of drill down into specifically which pod is, maybe running the bad actor, because especially if you have pods that are dense in terms of containers. If I pull up the containers view here at the bottom, this could be a massive list like it already is, because again, we're looking at the entire cluster. So we're including everything from Rancher and all of the other stuff that's running with it too. Now, again, if it's a really, really bad actor, it'll probably stand out really heavily for you. But if you just look at this list I'm hovering over right now, this is out of the box. So this won't be as useful. So this is where you may want to start customizing these dashboards, or just make a whole new one and scope these a little bit better to maybe like your particular services or your particular containers. So you can keep a closer eye on your stuff, and then always zoom back out if you notice that, maybe it's not your containers that are causing the problem, but there might be something else going on inside your cluster. I'm going to talk a lot more about your cluster itself versus just your services, even though I'm running some services in there right now. You can kind of see like where they're putting some system load and all that too. But if you notice, like I can't really see the trees in the forest right now. Like I'm looking specifically for mine. If I keep searching through here, I can't really see it right yet. Oh, there we go. There's the advertisement service. Like it took me a while just to get to that point. So drilling through and filtering through some of this stuff is a little hard to do right off the bat. It's not necessarily a bad thing necessarily, right off the saying it's not super bad, but it's that you don't really get a lot of like instant, drilling in. But I can still click and focus in on just that particular pod. I can do the same down here. If I go a little bit farther, I can probably find, there's my database, there's my discount service. So if I pull up database, there that goes. It's sending a lot of stuff that makes a lot of sense. It's dealing with a lot of transactional data. There's the discount service. So our database is doing a lot of reads. This correlates to, it's a lot of the negative numbers are basically outbound traffic. So this is where database and even like the discount service, which is also a read-only service, we're not sending any data to it, makes a lot of sense in here. But I have to, you notice I have to look at each individual one in order for me to kind of like drill into what exactly is going on, instead of getting the entire sort of overall look at everything. So if I need to drill into networking and look at my traffic and what's sort of happening there, and then that can also correspond to like availability. If you've got nodes that don't have a ton of network throughput, this could be a problem, especially if you're going to do any sort of like GPU heavy stuff and you don't have large network throughput on those. This is something you need to keep an eye on, just to make sure that especially if there's security issues, etc. That's a place to go look. And there's a similar sort of story. Now I'm done with the network I/O pressure here, but if we talk about overall memory usage, if we wanted to look at that, this is where we can drill into the same kind of view, except this is scoped to memory. And then we have the same goes for CPU. So we can look at kind of where the bad actors can be in terms of eating the cores. Now you folks are definitely browsing through that e-commerce app I deployed, because I can see that the CPU usage is going up and up and up, which is fine. It's still within bounds. So the average is still fairly low, just the current is spiking up. So maybe there's some particular issues in there that we might want to look at. But again, out of the box, I don't get things like traces to tell me where in the app that might be happening. So I can't look deeply into it. All I know is like this is kind of some smoke, possibly. If I see this graph stay up like this, so let me focus specifically on front end here. So if I zoom into just this graph and I see this and it's kind of averaging really high, all I know is that it's averaging really high. I couldn't tell you why necessarily. Maybe if I grabbed the logs and I looked at sort of the same time frame, if I go into the Elasticsearch side and all that stuff, and I go looking through those, and I feel like, okay, at this time, these particular queries are coming in, maybe that'll tell me. But if I'm doing something like open tracing and using a Jaeger cluster, or maybe open telemetry for that matter, it can potentially tell me what was burning up so much CPU. It can tell me maybe which particular code path people were taking that would show that number. So this is where having a more enhanced observability story is really, really useful, because you can see these signals of like, man, that was a lot of CPU. Why was that? Like, and answering that question of why is kind of that curiosity that should drive you to answer those observability questions, because that's where you can build better monitoring. Is if you can answer questions like that, like why is it doing that? Then and especially if you didn't know about it, if you just happen to be glancing through here and be like, that's a decent amount of CPU. It didn't set off my alerts, but that's a little concerning. This is where observability helps track and maybe predict those problems that are going on. So those are just kind of the things you get right off the bat inside the cluster view. I'm going to go over through one more view before I jump back out into the Rancher side of things to show you Rancher itself and kind of where that plays and everything. And then I'll try to answer some questions as I go through that. So hopefully that's been good there. I'm seeing a lot more questions coming in. This is great. So I'll answer what I can. Let's see here. All right, so let's go into, so we got the cluster side of things going. Some interesting, there's a few different ones here, but if you're going to be running your own, save your own install of Rancher, kind of like I'm doing right now, a thing you want to keep an eye on is your etcd cluster. Now, granted, Rancher is also going to give you a decent view into this as well. The reason why I'm talking about protecting your etcd cluster is if you're not using a managed Kubernetes, where you kind of hand that off to your managed providers, then this is where you have to keep a little bit of an eye on what's going on with your etcd cluster, especially when you run larger deployments. Because etcd, when you're running it on one node, is not great, because there's no, like, as long as you've got that etcd cluster backed up and you do regular backups and snapshots, that's a good idea. That way, in case you have a problem, you can restore the database and you should be mostly good to go as long as you do those snapshots regularly. But if you go the route of like a hosted one, you don't have to necessarily look at this as much, because again, all that stuff is kind of managed, monitored, and made fault tolerant by your provider. So that when you have that stuff, you're good there. And I know I said that it was a little bit more difficult, but it's not that much more difficult than the Rancher one. Like, I know I put it third down on the list, but it's still, again, like those top three are still just honestly the easiest, best way to go most of the time. But if you have a large team that is totally ready to rock with Kubernetes, then I would still do one of the first three or all three, and then do the fourth one where you're running your own Kubernetes cluster, because the big name of the game is making sure you protect that etcd cluster at all costs. and that means running at a minimum 5 copies. Sure, you can run the minimum 3, but I would run 5 or even 7 if you can do it. And the main reason is for the consensus algorithm and leader election and all that stuff too. The last thing you want is for your source of truth in your Kubernetes environment to have a split brain problem. That will give you headaches for days or hours as people are screaming at you. So it's definitely something to keep an eye on. I'll pull it up here because that way we can take a quick look at it. But there's not going to be a lot of information useful here, only because I'm only running one. So etcd is kind of in a, I'm the god here. I'm going to write all the things. So I'm not going to go over that today. I just wanted to show you that it's there. So when you have at least 3 nodes in that cluster, then etcd will be able to create a consensus. Won't be a great consensus because if you lose one, then you have an issue. This is why I said run at least 5 copies if you can do that. 7 is even more ideal. That's just for voting issues and things like that too, but 5 is a really good number to start with. And that's where you'll get this panel lighting up. etcd as a leader. This is where you have to do leader election and choose who does the writes, etc. That's where a lot of that stuff comes in with the distributed databases. So it's a very important thing to keep a very, very close eye on. So let's go back here. I'm going to go to the pods. Here we go. This is the other one I want to look at. So this is the more generalized pod view, and this is the more so if I was in that main that cluster view that I showed you folks before, this would be the next place I would pivot to inside of Grafana to go look at sort of more details and kind of more in context what is going on with a particular pod. So this is where I can choose the namespace and where my stuff is deployed. So if I was going to look, say, at like my e-commerce thing, I'm going to go into the default namespace, which is the one that's generated for you by default. It's a great name. And then I can look at any one of the services I've got deployed. So these are the pods that I got running. Here's my front end pod. So here's that one. Remember we talked about that spike in usage. Let's zoom out a little bit. Let's go to the last 15 minutes and look at that, more of that spike. There's that CPU spike. So this is where looking inside of the Grafana side of things versus Rancher is going to tell you a lot more of a story about what's been happening. Now, it's not to say that you can't drill into this, because like what I haven't shown you kind of on purpose is like, this is what you get immediately. It doesn't mean you can't open these up. So when you actually enable the enhanced metrics, you get some really cool detail too of like kind of the same sort of look you get with Grafana, except one, it's in context of everything else. So if you were freaking out when you see like, oh my God, what's going on with 80% usage, you can get a little bit more detail to see like, is this been going on for a minute or is this just happening? This is where you can get kind of that really quick look, because this is kind of giving you the same sort of look that Grafana is doing. It's talking to the same source. It's asking Prometheus like, hey, what's all the data for me? Can you provide that to me? It's talking to an API. So this is looking back at the last 6 hours, all that stuff. So this is where you can check out those golden signals-ish in a nutshell. Like you can look at a lot of them in one sort of panel. If you look at the more specific parts of the Kubernetes side of things, this is where you want to look at that saturation signal side of things, which is where your API server is getting certain amounts of requests. So this is where it's going to be talked to a lot about what's your current state. Rancher tends to be chatty with that, so you want to look at that and make sure that your API server is functioning correctly and can handle the load that you're throwing at it. You may need to allocate more to it. It's possible. You can change all that stuff. And then the big one to also watch for your saturation stuff too is when you start seeing failed pod schedules. This could be someone accidentally requested too much, or they put in some weird reservation that just doesn't fit on the node. It could also mean that maybe you tuned your affinity wrong. So like the specific settings that you want to like schedule pods in particular areas. Like if you change those things to incorrectly, or this could also point to like maybe you've got a different saturation problem going on where you've oversaturating your environment, you'll start seeing the scheduling failed pods start to spike up. Or it'll just be on average a little bit higher. And it could be that your devs are like, I want to deploy all the pods. And we're like, that's not cool. We don't have enough room for all the pods. Which pods do you want? That's where you gotta go and have that conversation with them and maybe show them like, yeah, so when you're scheduling your pod, it causes this, which does this. You can show them about what's happening there. I don't have logging enabled, so you won't see the logging stuff here. The events part is also helpful to look at because you can see sort of what's been happening with the operators. You can see like where I started going through and adding in the Prometheus operator and all that other stuff too. Now these can get aggregated into Datadog. I'll show you how that works in a little bit. But these are really useful to have, especially if you had, a continuous delivery pipeline drop in, a deployment for you, or synchronize like a Helm chart or something like that. You'll see kind of the actions that it's taking there. And it's a really good sort of record to see, okay, if all these are going nuts, this is where I can go to be like, okay, what's been going on in the cluster lately? Like what have people been doing? Is this a thing where the operator is being too aggressive or not aggressive enough? Or is it someone who's been messing with it a little bit and we need to see what is causing that new issue? So this allows you to drill into kind of a bit more of the why, or at least what was causing that why. All right, so let's go back here. All right, so I got the pods view, and this is where, again, you can look specifically at this stuff. So this is where you have the requested and the current. So like we have the minimum size for the pods here, and then we have the network IO. So this is where I can drill into each individual pod in case I see that. And within that pod, we can see how many containers are within that. This is a pretty lightweight pod, as you can see. So I got just that one container in here. But if you got a whole bunch here, if this drop-down menu is large, that could be a thing you need to examine and see if that's going to be part of your strategy. I couldn't tell you one way or the other if one strategy is better than the next. Some people have a philosophy that you should have the tiniest pods in the universe so you can schedule literal tons of them onto systems, and we're talking like hundreds if not thousands of pods. Others are like, I want heavyweight pods because we only have like 2 or 3 services to run and we have pretty big machines. So I want all of the services right next to each other inside of the pod. I don't want to expend the networking going across them. And that's also a very valid strategy. It's just both of those strategies come with certain consequences. So that's where you want to like try both of them. And then especially, we mentioned things like game days. This is where you want to like go in and, in here, I actually have, I've got my kubectl already configured to talk to this environment, because actually when you use the Rancher Quick Start, it does a little configuration under the covers, and I've done a little bit of monkeying to mess with my kube control, so that way it can talk to the cluster immediately upon provisioning. It's just a little environment variable it's setting. So when I do that, I can use that to go through and like maybe delete a pod or just kill something inside of there. And then we can see like how Kubernetes reacts to those sort of situations. Now again, don't do this on production, of course. But there are even services like Gremlin out there and all that stuff where you can install a Kubernetes operator that will go through and kind of mess with your environment, so you can kind of see different failure modes of like what would happen if your pod didn't completely come online. Do you do a rolling upgrade and all that stuff? Did your rolling upgrade take as you thought? Or what if you oversaturate a pod? What if you throw literally everything into your pod at once? Does that make it unschedulable? That's other questions that you can answer by trying those different scenarios out and write them all down and kind of write out hypotheses of what you think would happen. Like, what would happen if we threw 5 services into the front end pod? Like, would it be schedulable now along the other sides of them? Would my cluster get overloaded? My hypothesis would be yes. So if I threw in the database and a whole bunch of other stuff into the same pod, or if I put like my entire app, so those 4 separate things that I deployed out here, if I combine them back into one giant pod to rule them all, would I be able to run more than one copy, or would it just get a little too saturated and there'd be problems? The interesting experiments you can do and write those down and then go ahead and carry them out on a test environment ideally and see how that happens, like how that reacts. And you may be surprised at sort of what you believe Kubernetes might do and what Kubernetes actually does. And it's not so much that it's trying to trick you, it's just that there's a lot of different levers and pulleys you can grab in Kubernetes that are guided by what Kubernetes sees and knows about in your environment. So this is where I go back to that talk about observability. And this is, Kubernetes has a lot of information, and this is what sort of the operators do for you. Operators look at data, they're observing the data, and then on the monitoring component, which you configure, it will act upon that data as it sees fit. But I mean, you can tell it how to act upon that data. But when you don't have enough data, or you aren't even looking at that data correctly, you won't be able to predict what Kubernetes is going to do in certain situations. Not unless, one, you try them, but also observe what's happening when it does. And that's where you can kind of coerce Kubernetes into a more manageable situation. That's where you can see like, okay, I know a little bit more about what will happen if I schedule this pod against everything else, right? So let's go back into Rancher here. I will go ahead and take a few more questions here. When I start spinning up the Datadog thing too, I will take questions if that spins up actually. So let me do that first. So let me show you the sort of Helm integration that's inside of Rancher. So let's go back up to the local menu here and go to global. And there's an app section here. So we got clusters, which we're looking at right now. There's apps, settings, security, which is really good. I'm not going to play with this here, but this is really extensive in terms of what you can do out of the box. So if you have particular security needs, the authentication bit is really cool. If you are using federated authentication, this kind of simplifies that whole setup and access for you. So you don't have to worry about enabling accounts. So if you're in a Microsoft environment, you can use Active Directory, all that stuff. If you use Okta, which I'm kind of a fan of, you can maybe be running your own OpenLDAP, all that stuff. You can run a combination of all these two different ways to get into your cluster. This is an easy way to set all that up, but I digress. Let me go back to the app section that I was just mentioning before. So in here, this is where you can run multi-cluster apps. Now, this is kind of where the analog inside of the sort of Helm charts and everything comes along. Rancher manages their own. So if you go into the manage catalog section, you see a bunch of them already been configured, but the Rancher has its own set Helm charts. You can actually look at all these too. So if you go to the Git repo, they maintain them, they're all public. You can go see what they do. You can even suggest changes. So if there's an issue you had, and even if you're not yet a customer, by all means raise an issue. I'm sure they can work with you on that. If you are a customer, raise an issue through support. I'm sure a change will get done for you to resolve that problem. But I'm going to go back here and I'm going to launch a new app. So this is where you get kind of the pre-baked catalog, and partners are going to get favored heavily here. So even one of our competitors, Dynatrace, is in here, Kong. If you scroll down a little bit here, there is Datadog right there. There's a whole bunch of other ones here too. So if you want to really play around with kind of the app library, this is where you can get the Kubernetes dashboard that you might have seen before, especially if you're running like a mini kube cluster and you run the dashboard inside of it. That is an interesting way to get that up and running. But these are effectively all Helm charts. Helm is super awesome. If you haven't used it yet, very highly recommend it, especially Helm v3. It's so much simpler to run now than it was before, and it's gonna make everything so much easier in terms of Kubernetes packaging. So super highly recommended. So I'm going to go to the specific one here for Datadog. So I'm going to click on that. And what's neat is in each of these charts here, if I go to detailed descriptions, this is kind of all the stuff from the chart itself. So you can actually see sort of what the prerequisites are, any sort of details about how you want to configure it, what it's going to do. Sure, you can use the Helm commands, but I'm going to go through the actual interface because, hey, it's visual. We're doing this as a webinar. I can run the Helm install command and all that stuff too with my Datadog API key, but I'm going to actually do this configuration. Actually, I'll do this partly off camera because I don't want to reveal my API key, but I'll show you some of the basics of what I'll configure. So I'm going to name this something super sophisticated, Datadog. It's really, really descriptive. Naming things is hard in computer science. And then going to be whatever the latest is. Now, this is not the same as, we do have an official Helm chart that you can run as well. It's entirely up to you. If you go this route, this is probably going to be a lot more supported by Rancher, but not to say that they wouldn't necessarily support you running other Helm charts and stuff in their cluster. It's just that this is kind of their blessed path when you come in through this. So if you say like, hey, I set up Datadog and something didn't go right, this is where you can raise support from Rancher and even Datadog, and we will try to help you in that. And then this is where some of the interesting scoping comes in. So I'm going to talk about the cluster project sort of relationship here and how it kind of messes with some things, especially in the observability side. So in Rancher, they expand upon the cluster and namespace concept inside of Kubernetes by adding on one more layer. So a node node as they would call it within a cluster, can have many projects, and those projects can have many namespaces. Now you're like, okay, well, Kubernetes doesn't have a thing called projects. So the way that they kind of sneak this into the covers is for each project, there's a sort of generated code that gets prepended into each of those projects. So when you deploy something, especially through here, I'll show you where that kind of gets tacked on. it can make things a little interesting for when you're deploying certain Helm charts, or if you're like deploying your own services inside of there, because it will kind of mess with the namespacing a little bit. And then that's where you'll have to like consider how you do security policies within your Kubernetes environment, which will allow for observability tools to come in. So for Prometheus to be able to look at your services and all that stuff, or talk to them or reason them, it has to be able to actually reach the other projects. So I'm going to go ahead and add both the default and system projects to this, so we can kind of get a whole picture view into everything. This again can be sort of controlled based on what your policies are internally, all that stuff. I don't know how your setup is. I'm just going with this because it's the demo. I'm going to do an upgrade all apps simultaneously, just because, again, not really caring about doing a rolling update part here. You probably want to stick with this in the future, so that way you don't lose observability as it tears down and sets up new pods. You want to probably do that in a rolling deploy fashion, especially if you put in a configuration option that doesn't really agree with the Helm chart and stuff like that. If it doesn't apply cleanly, or if there's some other configuration within the pod that it doesn't like, it won't schedule the pod correctly because it won't be able to come into a healthy state. So if you do this, you're going to kind of get stuck in a bad space. So rolling update is generally pretty good to do. This would even go for your Grafana clusters as well. So if I'm going to switch this to the cluster role because I want it to have a lot more access to what's going on. I use a default Datadog image. That's fine by me. I'm going to go ahead and enable the cluster agent here. Actually, no, I'm going to disable that for now. There's a lot of information here, but the cluster agent can give you a lot more details about sort of what's happening within the cluster, the overall cluster itself of Kubernetes. So this isn't talking about cluster necessarily as just Rancher sees it, but the overall Kubernetes, like the health of the Kubernetes cluster. You can install this across multiple clusters or have multiple copies and have them separate from each other if you'd like. So you can deploy more than one of these if you'd like. You can name this like Datadog staging if you want, and Datadog production. So that way you can separate each sort of Datadog configuration and things like that. This would also go for Prometheus as well. If you want to scope each Prometheus install to a particular area, that will allow you to do so if you go into the Helm chart for those. So I'm going to do that, those two, and then I'll off camera do the API key at the very last second. But the site URL is a big one to do because we actually have two environments currently. We have the US environment, and then we also have the EU environment, which is Google Cloud Platform. So if you're deployed to Google Cloud and all that, it might be beneficial for you to go to the EU environment, or if you're based in the EU, this is a good place to go. DatadogHQ.com is the other option. There's the newer one for Azure that's coming up. We haven't gotten into that bit yet, but that will be coming soon-ish. Don't have an exact date for that yet, but that's on the way. And then I'm going to tell it to collect events. So this is where I'm going to correlate those event information that you see inside of Ranchers. I just had that in the Grafana list, but if I go back into, let me pull up a new page. Oops. Go back to new one here and pull this up. Clusters. So I just want to show you what I'm talking about here. So when I go back into the local dashboard here, the events here, so Datadog can actually take these in as Datadog events. So when any of these things change or happen, or something goes on with your cluster, Kubernetes decides to start killing pods left and right, you should start seeing those events occur, and those will get tracked in with your normal correlation of everything. So this is where you can kind of see side by side, okay, these are the events, this is what's happening, CPU spiking when it's starting to thrash a lot of the pods. This is where you can kind of see those two come together really quickly in terms of like that correlation. We have the APM side of things, which will give you those traces. We also have logs, which is also really important there, that can take in all of your information from your pods. So if your pods aren't starting for whatever reason, collecting the logs will show you that. The live process agent gives you significant more detail about what processes are running in your pods. So like you'll have the containers with their own processes, but you can see kind of what each individual process is doing. You do get this view inside of Grafana. So let me go back into the, I think it's under the nodes view too, because this is the full breakout here. It's either the node view or the other one, because there's system detail. So this is where we can get all the specific stuff about your system and your node. Let me go back to the cluster side. There we go. Okay, so yeah, when we look at more specific stuff, this is like where we can look at individual process usage, but we'd have to look at each of these. So this is where we look at CPU, then we have to look at memory, but we're not looking at them side by side. We don't see them sort of in context. We can rearrange this dashboard, of course, but this is what you get out of the box with Grafana. So if we're comparing the two here, it's like we don't see them sort of in the same, not in the same view. Like I have to go down here to look here, and I have to go back up here to look here. I'm sure you can fold these up, but like out of the box, you don't really get instant information and like sort of everything in one place in context. So that's kind of what I was talking about there. And then we're going to do the kube state metrics deployment as well, so we get a bit more detail about what's happening inside of Kubernetes. So this goes in with the collecting events stuff as well. This gives you even more detail about sort of what the scheduler might be doing, or what each of the sort of deployments are going on, all that stuff. So let me off camera do this real quick here. I gotta fill in an API key. Don't really want to give my API key on the air. Have done that before on accident. We all make mistakes. There we go. All right, so all I did was I just launched that. So now that I hit launch, I get back into the multi-cluster apps. And then as it's installing and deploying, we actually see that since I picked both, the two projects that it was targeting here, got local default, local system. So if I click into any one of these, I can actually see the deployment live as it's happening on TV here. So we've got Datadog agent, and then the kube state metrics going alongside of it as well, because it's from CoreOS. So this will give us a lot more detail about sort of what's happening within the Kubernetes environment, and sort of what it's doing, what it's thinking, that sort of thing. So you get a little bit more details versus just like some measurements of numbers. You get a bit more about like what actions it's deciding to take. All right, so that's up and running. Got the workloads already deployed. Go back here. All right, everything's green. So I'm going to pull up Datadog here. So app Datadog HQ. Okay, it's going to take a second for this to saturate. So let me see if I can answer some more questions. We'll kind of coast into the Q&A area because I'm getting very close to the end of the demo here. I'm not going to go too deeply into Datadog. And the main reason why is because it will take a lot more to set up all of the things if I was just going to like turn on everything at once. And also even then it would take a good 10 to 15 minutes to get everything to really show up versus I've given Grafana a lot of time to kind of saturate and light up that dashboard. Not to say that Datadog is slow and takes forever. It's just we only have so much time, and I would love to show you that, but I'm keeping it short and everything to value your time. So let's get more into the question side of the thing, and I will go and show Datadog a little bit more as well. So let's see here. Yes, yep, it is definitely recorded for later viewing, that's for sure. I guess we can go back and forth if you want, if there's any Rancher specific questions, I can pass those off to you. Let's see here. So let me see if I can remember where I left off. So how do you grab app metrics and send to Datadog? This is where we have some interesting integrations into Kubernetes. So when I deployed this out and everything like that too, Datadog has a few different ways into your Kubernetes cluster, and this sort of depends on how you deploy it and sort of how much information you want to collect. If you were asking me, I would say collect everything, which is generally the answer there. You can always pare it back, or you can just go very slowly and deliberately. You can just turn on specific things and go from there. It might be better to actually start with small and work your way up. That way you're not overwhelmed by the sheer amount of information. Because like right off the bat, I've already started configuring all this too. If I go to the events view here, full disclosure, I've been setting up and tearing these down here, so it's been longer than an hour, so you can see all the newer events. So this is the Docker events that have gone on. Here's my Datadog agents. They are spun up and running. Yeah, so there was a whole cluster I spun up before because I was running some practice runs on this stuff too. But this is where you get those events. They will come in through this view in particular. And we group them together so you're not getting spammed. So if you want to see a lot of similar events in context, the blurring you're seeing there is an API key that I keep hidden under wraps, but there's also like part of an API key in here. It's not even the whole API key. We don't expose details like that. It's just something I filter out locally on my thing because I'm used to giving live demos and I don't want to reveal my API key. I'm generally paranoid about that. So don't worry, that's not some weird bug in our app. That's just me. So if we go to Now the dashboard section, we will give you, depending on the integrations you enable, some of them will come with out-of-the-box stuff. So if we look into like the Docker one, because we're using Docker to to sort of deploy and run everything right off the bat, we get this automatic baked-in view of kind of everything going on in the Docker universe. And this is a lot to take in if you haven't looked this deeply at Docker, but it's worth knowing and looking at because Docker is the thing that's powering your Rancher cluster off the bat if you're just starting with the defaults of everything. Yes, there are other options for running your containers, but Docker is by far the most popular one right now. This is where you can look, the breakdown by image, and this is where you can more specifically look at that same container view you saw in Grafana. This is where you can look more specifically at those containers and kind of what their usage is, and we can kind of give you the stacked rank thing of like, these containers were eating a ton of CPU, might be worth looking at. So if I click on any one of those, this is where I can pivot and bounce between different areas of Datadog. So this is where you can kind of follow the trail versus you can't quite do that in Grafana. There are some methods to doing this, but again, it's assembly required. Remember, like I said before, like you don't get a ton of that stuff right out of the box. You got to build a lot of that stuff yourself. But the nice thing about having the single pane of glass is like we can actually use this as pivot points. I can blow this up to full screen, but then I can look at the specific hosts, like which host was that container on that was eating a lot of CPU. So if I bounce to that, this will kick me over to that particular view. Oh, there's no matching host because I have availability zone turned on by default here. And where was that? What? There should be a host here. Come on. I thought I had a host metric in here. Oh, it's not reporting the host yet. That was a fault on my part. It's, again, this is where I needed time to fully bake everything. So I'm going to go back into the containers view. Sorry about that. It's not ready yet. I'm waiting for more information to come from the cluster itself. So I'm going to look more at the containers view and things like that. So give me a second. Let me pop back out here. I'm going to go back to the Docker view because I like the Docker integration, but this is probably the most I can show you right off the bat without turning on a lot of options inside of my system. Let me see if I can answer some more questions here. So we'll just coast into Q&A while I kind of bounce around Rancher and Datadog. How are we doing on time?
Yeah. Hey, Aaron, I was just going to mention there's a lot of really good questions here. So if we could
let's get to that.
Try to get to those. And we are running a little bit short on time. I think we have a little bit under 15 minutes left to wrap up. So
let's do that. Okay, so I got the text one. Yeah, it's recorded. Trying to go. Wow, there's a lot of questions here. Thanks for participating. This is great. Let's see here. How does using K8s with Rancher plus Datadog compare to KOPS? KOPS. It does look really nice. What are the main selling points of the setup versus something like KOPS? I'm trying to remember what KOPS stood for. There's so much alphabet soup going on here. And the other thing, let's see if we can even just do a quick search for that. What I'm talking about. Kubernetes operations. Yeah, so I haven't messed too much with KOPS in particular, Kubernetes operations. Yeah, sorry. I was thinking some other thing inside. There's so many acronyms in this space. I can't really speak to that in particular. I haven't really looked at that too much. So this is kind of where my gap of knowledge of that is. I would love to answer that one offline though. So I'll make sure we take note of that and follow up with you. If you can, just reach out to me after the call. I'd love to kind of like dig into that and see if I can give you a better answer about that. That's an interesting question, yeah, because I've heard of it. It's just been a minute since I've heard that particular acronym. There's so many of them, and they float around in my head all the time. Sorry, I don't have like a full answer for you right there. I wish I had a more authoritative answer, but I won't answer something if I don't know confidently what's up. Let's see here. What was the GitHub URL for the demo site? There it is. I'm gonna leave that up there for you. It is github.com/datadog/ecommerce-workshop. There it is. I'll leave that up there so you can see it on the screen. All right. You can use several pods in this Grafana GIFs if anyone's interested. Yes. So yeah, I did gloss over that. So if I wanted to look at several pods at once, so if I was looking at the pod section here, not that pod section, this pod section. So if I was looking at all the pods network IO, if I was going to select certain ones here, I can group them together. Yes, that is true. So if you need to know like how to look at multiple pods, this would be one way to do that. So if you need to correlate several pods together to kind of compare the usage, especially if it's your services versus say the Kubernetes services, that is a very good thing, good pro tip for you when you're looking at Grafana in particular. You can also turn them completely off and be like, I just want to look at all the things or just one of the things. I want to look at just Prometheus. But then if I click on it again, it zooms back out to everything else. So definitely something to remember. Good pro tip. Thank you for that. Let's see here. We talk about Datadog in this live or just another Rancher. Well, no, it's going to be mostly Rancher, but Rancher very specifically wanted me to talk a lot more about the open source side of things and kind of where even Datadog fits in that ecosystem. If you want like a real sort of big Datadog overview, I would highly recommend you join our webinars for that stuff, or you reach out to me and we can schedule something more of like a personalized live demo for you if you want to go that route. That way we can kind of tailor that more to sort of your wants and needs and kind of what you're already getting out of your Kubernetes environment. That I think is better than doing in sort of this kind of context. Because it's observability is a very wide space, if you haven't already gotten that from my presentation plus this demo, is it's a really wide world of stuff, and it does feel overwhelming, yes, but it doesn't mean you can't sort of dig your hands in and sort of like build that knowledge as you go. I just think that the Datadog story of doing that is a lot simpler than all of this stuff, but I do want to show you that there are options out there. You're not completely alone and by yourself if you're doing this stuff through Rancher. Rancher gives you a lot of tools right out of the box that you can already play with. And then even go over the sort of alerting side of things, because that is also configured for you by default. So if I went back into that local cluster here, I can go to tools and alerts. And you actually already had this because Prometheus is also one of those things that can look at those signals and tell you something's wrong. And again, this is where you need to learn PromQL for that. But if you want to take a peek under the covers of what's there, this is where you can look at each of those things. So if I want to see like, okay, there's high CPU load in the system. How do they find that? I go to edit on the little ellipses there on the right. So each of these little things here, if I click on this guy right here, edit, I can now look at the PromQL expression. So if you don't really know PromQL and you want to look at it, that's a good way to start. It's actually how I kind of learned initially with some of the stuff when I first started playing with Rancher 2. That was the way I started learning Prometheus query language, was just by looking at some examples and kind of tweaking and going from there. I ultimately read a book on it, but it's something to definitely look around and play with, like just start with the out of the box stuff and see where you go from there. Like even by default, I'm not configuring any notifiers. I'm not telling it to tell me what's going on. So this is another thing you can look at. Okay, so yep, we already did the Datadog deploy using Rancher. Now it's not a complete deploy. I didn't add in everything. Again, sorry, because I'm just stuck on time. I need to provide some time for talking about everything and answering questions. Sorry about that. Let's see, can you show how to configure Datadog dashboard from Kubernetes agent and see live in the mesh and change distribution? I'm not entirely, this feels like there's a few questions compounded into here. So I'd love for you to reach out to me afterwards, but I'm thinking what you're asking is how can you configure the Datadog agent from the Kubernetes agent itself? It would actually be better if you did your dashboards through a more automated tool like Terraform. We do have integrations with that. You can build dashboards that way. I would stick more to that. So if you're going to end up going with something like Datadog, by all means, look into a tool like Terraform, which can automate and sort of through sort of open controls within your organization. So you can use stuff like GitHub, GitLab, and all that to modify and manage your dashboards versus just a bunch of people going through. Yeah, you can click and change the dashboards themselves. So if I clone this dashboard, I can make my own copy of it. And then it will kick me over to it there. And this is where I can start making changes to it. I can modify the widgets, but it's not necessarily very democratic or deliberate within the company. It's not communicating why I want to change these things. So that's where you may want to look into automation tools like that. So notice that Kubernetes, Prometheus, and Grafana sometimes report different memory and CPU usage. That is correct. Kube has a particular view on the things. They all generally watch roughly the same metrics, but for lack of going into super depth, some of them interpret those metrics a little bit differently. And it really depends on sort of those views into it. So Prometheus itself should be collecting roughly everything else it can from Kubernetes and what it sees, along with Prometheus is going to have its own kind of idea, and also anything that's speaking open metrics, remember, it can go through that and look at it. Grafana is talking directly to Prometheus, so I'm not sure why Grafana would show you something that different. because remember there's a lag time, and do you remember like you have this little timer up here? You can have it go super granular. You can do 5 seconds if you want, which is going to kind of eat up a little bit more network as it's pushing more data to you. But depending on your collection rate and stuff like that, you'll hopefully have some good reactions in here. But I'm curious of like how different your view is, because again, Grafana is talking directly to Prometheus, but it could be like maybe your PromQL is asking a very particular question, or maybe it's doing a rounding error, because you can do that stuff in PromQL. You can massage the math a little bit. Let's see here. Yeah, that's how come they can be different. That was in conjunction with that. Yeah, like I said, they can be different, especially if like by the time it gets to Grafana, when Grafana is running those Prometheus queries, if you do some weird rounding or something like that, then Grafana can give you a very different look at it versus what Rancher will show you, because Rancher is doing its own sort of Prometheus queries under the covers. I don't know if you can actually look at those inside of Rancher. That'd be something for Rancher to answer to you. I've never really gone looking for that in particular. I like what's there out of the box. It's pretty good. Let's see here. Next one, how can Datadog be deployed and utilized in air-gapped environments? Oh boy. So Datadog in air-gapped environments is difficult. We don't have a behind the wall firewall install yet or anything like that. I couldn't tell you any status about that. If you got specific air gap requirements, or like what you need to, like if you can still get some kind of a proxy to get that data out to us, that'd be great. If not, if you are truly air gapped and you cannot send data out to another service, then absolutely you want to look into something like Prometheus or Thanos and Grafana, and you're going to have to scale up pretty hard on that. Because if you've got air gap requirements, you probably have other requirements on top of that that require you to like really keep everything tight and close. And definitely, yeah, you'll have to go down that route. Like Datadog isn't going to be the perfect solution to everything, as much as I would like to say that is. If you got very specific or particular needs like that, we unfortunately aren't going to be that option for you right now. So I will definitely admit that on the air. So any information on when recommended monitors will go into general availability. It should already be there. What they're talking about is the monitors section here. So on the Datadog side, there will be a newer feature. I think right now it's in sort of like super open beta, but it might have already gone GA at this point. I need to double check on that. But what you'll see on this side, once we start gathering more data on your system, we will give you a bunch of out of the box, ready to go new sort of suggested monitors. Like, we think you should be looking at CPU with this certain number based on your environment, that sort of thing. So if you go into a new monitor here, you'll see recommended monitors. Here's the beta right up here. So I've already got access to the beta. So yeah, it's definitely open beta now. It's just not GA yet. Don't know when it's GA. Probably going to be soon, is my guess, because it's been in beta for a bit, but don't have a timeline for you. But you can definitely at least access it now. I know we've been still seeking feedback from customers. So if you are a customer and you've been using this, please use the little chat button and talk with us, because we'd love to hear your feedback about that so we can keep improving it. And Kubernetes operations, yeah, that's what COPS is. Gotcha. All right, so okay about COPS, gotcha, cool, thank you. Yes, all right, cool, got to the end, sweet. I wanted to make sure we read through everything before we closed out, so. All right.
Yeah,
so
lots
thanks,
of great
everyone.
questions.
Yeah, too many of them. This is awesome, I love it.
Great, well, thank you, Aaron. Just any last words or recommendations before we wrap up today?
Yeah, I would definitely say with observability, it's very much a journey. Like, observability and monitoring are absolutely a journey. And ultimately it's a destination you want to just live in, and then that destination will shift on you. So being aware of your environment, and the more aware you are of your environment, is kind of where you gain that total control of knowing what's going to happen and where, because there's so many variables when deploying stuff. But the cool thing is there's a lot of people interested in this space. There's a lot of discussion about this space. So I absolutely encourage you to go join it and check it out. It feels overwhelming, but once you're in it, you're like, oh, this makes sense. I don't know why I wasn't doing this before.
Sounds good. Thank you so much for your time today, Aaron. This was a great session, tons of great questions, and I know people were asking about the GitHub repo, so feel free to pop that over to me and I can share it in the follow-up email.
Absolutely, yeah. The one thing I'll leave you with too before I jet is if you are Kubernetes folks and you are Datadog folks, we do have a beta that is up and running that we'd love more feedback on too. So if you've already deployed, we have an internal beta that you can get to. Also have them linked to this blog as well. This is an entirely different, not entirely different, but it's a more centralized view that's aimed specifically at Kubernetes deployments. It's kind of like the Grafana and Rancher dashboard had a crazy love child that gives you all the information you really need to know at once. Like here's a screenshot of that. I didn't show that off today because like I wasn't able to get that working in the demo in time. But you can gain information about like what the YAML is on the pod deployment. You can look at the status, whether or not a pod was evicted. You can then use monitors on those to see if you have a lot of evictions going on, which again could be one of those signals to tell you something might be going on here. So that's currently in beta. So, which is to say, again, since it's beta, it may not be perfect, but it would be something to definitely dig into and check out because it gives you some really interesting viewpoints into your cluster, especially if you run large clusters or a lot of clusters. By all means, super, super, super useful.
Looks great.
Yeah, I'll make
Thanks
sure we
again,
link to that
Aaron.
at the end.
Okay.
Yep. Thank you so
Sounds
much,
good.
Rancher, and thank you everyone else for tuning in.
Great. Thank you, everybody, again for coming today. Look forward to seeing you guys at one of our future Kubernetes masterclasses. Thanks again to Aaron and the Datadog team for your time today.
Thank you.